Jupiter is the largest planet in the solar system. 1,321 Earths fit inside it. It has been spinning for 4.6 billion years, and it has a storm that has not stopped for at least 350 years. We have sent spacecraft there. We have mapped its clouds, measured its gravity, and photographed its poles for the first time. And what those instruments found inside Jupiter has forced scientists to discard theories they held for decades. This video covers 7 of those things. Every single one is documented. Every single one is real. And by the end, you will understand why scientists who study Jupiter choose their words very carefully when asked what is actually going on in there. But before we get to the ocean of liquid metal, the core with no boundary, and the lightning strikes potentially 1,000,000 times more powerful than anything on Earth, we start with something at the poles nobody knew existed until 2016. Number 1, the poles are covered in permanent storms the size of Australia, and nobody knows why they stay fixed. For most of human history, nobody had seen Jupiter's poles. Every spacecraft sent there before 2016 flew along the equatorial plane. The poles were blank gray areas in scientific maps. NASA's Juno spacecraft changed that on July 4th, 2016. Its polar orbit sent it directly over both poles for the first time. Both were covered in permanent cyclones, not temporary weather. Permanent, organized storm systems in the same positions across every orbit Juno has completed since 2016. At the North Pole, one central cyclone, approximately 1,864 miles across, is ringed by 8 more in an octagonal pattern. At the South Pole, a central cyclone is surrounded by 5 others in a pentagon. Each circumpolar storm is up to 3,100 miles wide. Wind speeds reach 220 miles per hour. Scott Bolton, Juno's principal investigator, stated directly that the planet is home to gigantic polar cyclones, bigger than Australia. A paper in Nature Physics in January 2022 confirmed they are driven by moist convection. Physical oceanographer Leah Siegelman, who led that study, said when she saw the turbulence around the Jovian cyclones, it reminded her of ocean eddies on Earth. 8 at the north, 5 at the south. That count has not changed across years of continuous observation. Why the specific numbers and why they differ between poles has no published explanation. Scientists at the Weizmann Institute showed in Nature Geoscience in July 2021 that the storms hold their positions through competing pressure forces. Why 8 and 5 rather than any other combination remains unanswered. Before Juno, nobody knew any of this existed. What it found deeper inside the planet was stranger still. Number 2, there is an ocean of liquid metal tens of thousands of miles deep. About a third of the way toward Jupiter's center, pressure becomes so extreme that hydrogen stops behaving like a gas. Electrons are ripped from atoms entirely. What remains conducts electricity the way metal does. Scientists call it metallic hydrogen. It does not exist naturally anywhere on Earth. Inside Jupiter, there is an ocean of it tens of thousands of miles deep. Jupiter's magnetic field, the strongest of any planet in the solar system, comes from this ocean. As Jupiter spins once every 9 hours and 55 minutes, the fastest rotation of any planet, this conducting fluid churns and generates electrical currents. Those currents produce the magnetic field. The field is approximately 20,000 times stronger than Earth's. The magnetosphere it creates extends 21 million kilometers toward the Sun, 15 times wider than the Sun itself. If visible from Earth, it would appear larger than the Moon. Inside that magnetosphere, radiation belts trap high-energy particles. The European Space Agency's technical documentation states these belts are the most hazardous in the solar system outside the Sun. The Galileo spacecraft, orbiting Jupiter from 1995 to 2003, experienced repeated failures from radiation. Electrical arcs caused it to enter safe mode multiple times, wiping data from 3 complete orbits. Juno was built with a reinforced titanium vault around its core, electronics specifically to survive the environment. When Juno measured the field close to Jupiter, Jack Connerny, Juno's deputy principal investigator at NASA's Goddard Space Flight Center, said the field looks lumpy, stronger in some places and weaker in others. The exact mechanism driving Jupiter's dynamo remains under active research after nearly a decade of Juno data. Researchers at the University of Rochester studying this problem stated plainly that it is a shame we do not have metallic hydrogen. Naturally here on Earth, but on Jupiter there are oceans of it. What lives inside the storms powered by this magnetic environment belongs in a category most planetary scientists did not anticipate. Number 3. The lightning may be 1,000,000 times more powerful than anything on Earth. Jupiter has lightning. Almost every spacecraft that has passed by has detected it. The flashes stand out on the night side from millions of miles away. Storms producing them can be bigger than Earth, and some have been running for decades. For years, researchers believed Jupiter's lightning was comparable to the most powerful bolts on Earth. Then Juno's microwave radiometer returned data that changed that completely. A study published March 20th, 2026 in AGU Advances, led by Michael Wong at UC Berkeley, analyzed 613 lightning signals from Juno. The strongest bolts reach at least 100 times the energy of a standard Earth lightning strike. An average Earth bolt releases about 1 billion joules, enough to power 200 homes for an hour. Wong's team acknowledged the measurements are likely an underestimate, since Jupiter's bolts also release thermal, acoustic, and chemical energy not captured in radio measurements. The actual energy range was estimated at 500 to 10,000 times Earth lightning. The upper end of the uncertainty range pushes toward 1,000,000 times more powerful. Jupiter's atmosphere is mostly hydrogen. Moist air is heavier than dry air on Jupiter, meaning storms must build enormous energy before they can rise and release it. Storm clouds also reach more than 60 miles high compared to roughly 6 miles on Earth. More height, more pressure difference, more stored energy before discharge. Wong's team could only isolate precise measurements during a rare lull in North Equatorial Belt activity in 2021 and 2022, when individual storms could be tracked separately. Outside that lull, dozens of overlapping storms across the planet make individual measurement impossible. How powerful the largest bolts in Jupiter's most active regions actually get has not been measured. Before we move on, if you're enjoying this analysis, please consider subscribing. It helps the channel tremendously. The storms producing this lightning are rooted far deeper into Jupiter than anything visible from outside. How deep became clear when Juno flew directly over the most famous storm in the solar system. Number 4. The Great Red Spot has roots 500 kilometers deep and has not stopped for 350 years. The Great Red Spot has been documented continuously for at least 350 years. As of 2017, it measured 10,000 miles across, 1.3 times Earth's diameter. Its winds race counterclockwise at over 400 miles per hour. During Juno's first pass over it in July 2017, its microwave radiometer detected the storm's warm signature to the limit of the instrument, at least 240 kilometers below the cloud tops. A follow-up study published in Science in October 2021, led by Juno scientist Marzia Parisi of NASA's Jet Propulsion Laboratory, used gravity measurements across 12 Juno passes, including 2 direct overflights. By measuring tiny shifts in Juno's velocity caused by the storm's mass below, the team confirmed the Great Red Spot extends to at least 500 kilometers below the cloud tops. Andy Ingersoll, professor of planetary science at Caltech and a Juno co-investigator, stated the roots go 50 to 100 times deeper than Earth's oceans. Scott Bolton said the storm goes as deep as Juno can see, and may go deeper still. The 500-kilometer figure is a confirmed upper bound, not a discovered floor. Jupiter's entire visible cloud layer spans about 44 miles. This storm's roots reach more than 7 times deeper than that, below the water condensation zone, below where any sunlight penetrates, into atmospheric layers never directly observed by any instrument. The spot has been shrinking. In 1979, it was twice Earth's diameter. Now it is 1.3 times Earth's diameter. Juno has observed streamers peeling off its edges that may be connected to the shrinking. Why a storm that has survived 350 years with 500-kilometer deep roots is now contracting has no published answer. What Juno found at Jupiter's center, beneath all of this, overturned a model planetary scientists held for decades. Number 5. The core has no boundary and nobody can explain how it formed. The standard model was simple for decades: a small, dense, compact core of rock and ice at the center, roughly 10 to 20 times Earth's mass, surrounded by clean, distinct layers of metallic hydrogen, then liquid hydrogen, then gas. Juno demolished it. By measuring tiny velocity shifts during each orbit, Juno mapped mass distribution inside Jupiter with precision no ground telescope could achieve. The core has no defined edge. Heavy elements blend outward into the surrounding hydrogen without a transition zone. NASA's official Jupiter facts page states the core is partially dissolved, with no clear separation from the metallic hydrogen around it. Scientists call it a dilute core, or fuzzy core. It extends 30 to 50% of Jupiter's total radius outward. For years, the leading explanation was a giant impact. In August 2025, a team from Durham University, in collaboration with NASA, the SETI Institute, and the University of Oslo, published results in the monthly notices of the Royal Astronomical Society. They ran high-resolution impact simulations on one of the UK's most powerful supercomputers. In every single simulation, the displaced core material settled back down and reformed a sharp boundary. Not one simulation produced a stable dilute core. Dr. Thomas Sandness stated directly that the impact shakes the planet to its core, just not in the right way, to explain what Juno observed. Saturn also has a dilute core. Dr. Luis Teodoro of the University of Oslo said this strengthens the idea. These structures form gradually during planetary growth, rather than from rare catastrophic events. How Jupiter's core formed remains open in the current published literature. The temperature at the core boundary is estimated at approximately 20,000 degrees Kelvin. That is hotter than the visible surface of the sun. What sits between that core and the cloud tops brings in something that should not be possible for a planet this far from the sun. Number 6. Jupiter produces twice as much heat as it receives from the sun. Jupiter emits nearly twice as much energy as it absorbs from the sun. This is confirmed and documented. NASA's Star Child reference page states directly that Jupiter emits twice as much heat as it absorbs from the sun, which indicates it has its own internal heat source. A study using Cassini spacecraft observations published in Nature Communications measured Jupiter's internal heat output at 7.485 watts per square meter, significantly higher than previous estimates. That measurement covers the entire surface area of a planet 312 times larger than Earth. The mechanism is gravitational contraction. Jupiter formed 4.6 billion years ago and has been slowly compressing under its own gravity ever since. Wikipedia's Jupiter entry, sourced from planetary science literature, states this process causes Jupiter to shrink by about 1 millimeter per year. The The gravitational potential energy of that compression converts into heat. The planet is still radiating the energy of its own formation. This internal heat is not a minor footnote. It drives the atmospheric convection that feeds every storm visible on Jupiter's surface. It drives circulation in the metallic hydrogen layer that generates the magnetic field. It powers the polar cyclones. Every visible feature of Jupiter, its cloud bands, its storms, its colors, draws energy from a planet that has been generating its own heat since before Earth existed. The Kelvin-Helmholtz mechanism responsible for this process is the same one that would cause a brown dwarf or failed star to radiate. Jupiter has the same ingredient list as a star. If it had been roughly 80 times more massive, it would have ignited nuclear fusion and become one. It missed that threshold, but it still generates and releases its own energy, and will continue doing so for billions of years. What nobody has fully characterized is the exact rate at which Jupiter's interior is still contracting, and how the heat moves from the deep core region through the metallic hydrogen layer and into the atmosphere. These processes interact in ways current models describe incompletely. The last entry connects Jupiter's interior directly to a question scientists are now spending billions of dollars trying to answer about the rest of the solar system. Number 7. Everything inside Jupiter is a model for searching life elsewhere in the solar system. Jupiter's moon Europa has a confirmed liquid water ocean beneath a frozen crust. NASA's Europa Clipper launched in October 2024 and is headed there now, arriving in 2030. The reason NASA spent over $4 billion building that mission connects directly back to what Juno found inside Jupiter. Everything driving Europa's ocean, the tidal forces from Jupiter's gravity, the potential hydrothermal vents on its seafloor, and the chemistry of its water, is powered by the same planetary system Juno has been measuring. Jupiter's gravitational field squeezes Io so violently that Io is the most volcanically active body in the solar system. Juno confirmed in December 2023 and February 2024 flybys that subterranean magma flows exist beneath Io's cooled crust. The same tidal mechanism acts on Europa, generating heat in its interior that keeps its ocean liquid 400 million miles from the sun. Mary Wojtek, director of NASA's astrobiology program, stated at a public event that there is good support for the hypothesis that life began at hydrothermal vents, and that microorganisms found at vents trace back to ancient lineages. The conditions inside Europa's ocean, dark, pressurized, chemically rich, and heated from below, match what produces life in Earth's deepest trenches. NASA's Subsea program, which ran from 2017 to 2019, sent researchers to Earth's deep ocean hydrothermal systems specifically to practice the science of searching for life in conditions that mirror what Europa likely contains. Every model those researchers built drew on what Juno was simultaneously measuring about Jupiter's gravitational and magnetic influence on the moons around it. The interior of Jupiter is not just an extreme environment for its own sake. It is the engine that heats the most promising candidates for life in the outer solar system. What Juno found inside the planet is therefore not a closed question about a gas giant. It is the foundation of where humanity is looking next. Verdict: permanent cyclones bigger than Australia at both poles with no explanation for their exact counts. An ocean of liquid metal generating a magnetic field 20,000 times stronger than Earth's, and radiation belts that cripple spacecraft. Lightning potentially 1 million times more powerful than anything on Earth with the true ceiling still unmeasured. A storm running for 350 years with roots 500 kilometers deep whose bottom has not been found. a core with no boundary that 2025 supercomputer simulations confirmed cannot have formed the way scientists believed. A planet emitting twice as much heat as it receives from the sun, and a gravitational engine heating the oceans of moons, where NASA is now searching for life. Juno arrived July 4th, 2016. NASA extended its mission twice. A second extended mission began October 2025. Scott Bolton stated that from its very first data pass, Juno revealed Jupiter as a complex, gigantic, turbulent world, even more than scientists had predicted. Jupiter is 1,321 times the volume of Earth, 318 times its mass, and 4.6 billion years old. Most of what is inside it remains unmeasured. If you enjoyed this video, make sure to subscribe. Thanks for watching, and we'll see you in the next one.